Video, we are going to derive the reduction formula for the derivative of cosine n to the x dx. Remember, this one implies to the derivative of cosine to the nx n minus 1, then multiply by cosine x. These and these are the same according to the laws of logarithms. From here, we can apply integration by parts by assigning u, let u be equivalent to cosine n minus 1 to the x. Then now du will be, using power rule, n minus 1 cos n. Now this will be minus 2. Then the derivative of cosine is negative sine, but that negative will occupy this space here, so that here we remain with sine x, then dx. Then the formula for integration by parts requires the part of dv and also v. Our dv automatically will be cosine x. Then the derivative of cosine, not the derivative, the integral of cosine is sine x. Now from the formula which states that the derivative of u dv is equivalent to vu, then minus the derivative of v du. This is equivalent to this, which is integral of cosine n minus 1 x, which is equivalent to v is sine x, then u is cos n minus 1 to the x, minus the integral of v is sine x. But what is du? Du is negative n minus 1. So when you bring that negative n minus 1 outside the integral sign, it will change this to positive. Then we shall have n minus 1 out here. Then the remaining part of cos n minus 2 to the x sine x dx will be outside. From here, we now narrow down. We must go with this part because for the future reference, we will take cos n minus it is n, to the x. Here it is n because we are finding the reduction formula for that, which is equivalent to sine x cosine n minus 1 to the x plus n minus 1 to the integral of, when you take sine multiplied by sine, that is sine squared x, then multiplied by cos n minus 2 x dx. Now from the double angle formula of sine squared x cos squared x is equivalent to 1. Here sine squared x will be equivalent to 1 minus cos squared x. Now replace sine squared x with 1 minus cos squared x here, and this will give you the integral of cos n to the x equivalent to sine x cos n minus 1 x plus n minus 1, the integral of 1 minus, now we replace sine squared x with 1 minus cos squared x multiply by cos n minus 2 x dx. Yes, dx. Now from there, we now open the bracket by distributing dx on each side, and this will be here, implying 1 multiplied by cosine n minus 2 will be cosine n minus 2x with its dx, then minus, when you multiply cosine squared x with cosine n minus 2, it is a multiplication sign. Therefore, we shall take the powers and add them. It will be 2, the power of that cosine is 2, then plus n minus 2, the power of this. This and this will cancel. Then now we shall remain with the cosine sign, now raised to n and dx. And here is n minus 1. Now consider this part, cosine n dx. It is equivalent to this part, cosine n x dx. We shall collect the like term. And remember here we have 1. So 1, the integral of cosine n x dx. Now this one, when it comes to this side, first you will open the bracket after distributing the dx sign. This n minus 1 stands for all of it. It means this will be n minus 1 into cosine n minus 2 x dx, then minus n minus 1 into cos n dx, then x here. Yep. From there now we can collect the like term. This one will be positive. When it comes to this side, it will be positive n minus 1, the integral of cosine n x dx. Now 1 plus n minus 1, 1 and 1 will go and get 0, and we shall remain with n. So it will be n, the integral of cosine nx. And remember, after adding we shall only consider one part of the integral, and we have dx, which is equivalent to, now we narrow down to this one, which is sine x cos n minus 1 to x, then plus n minus 1. Now this part, which was cosine n minus 2x. Now we wanted to get the reduction formula for cosine n to the x. We divide by n so that we distribute it each side, so that we remain with cosine n to the x. Divide by n, here there is 1 all over n, then here all over n. So this one will cancel, and now our reduction formula finally will be the reduction formula of cos n to the x dx will be equivalent to 1 all over n sine x cosine n minus 1 to the x plus n minus 1 all over n, the integral of cosine n minus 2 to the x dx. Thank you so much. Meet me in another video for derivation of reduction formula for sine n to the x. Thank you.